question we may take for granted is how we know where we are. If you're in a place you don't know and you need a general idea, you might take out your phone and use GPS. This is great for when you only need to be accurate within a couple meters or so, but what if you're a robot shooting a basketball and you need to know how far you are from the net? GPS just isn't accurate enough for this. This situation is exactly the problem that made me interested in the first place on how robots know where they are. There were three main solutions that I found feasible when figuring this out. The first was odometry. Essentially, you're going to measure how many times the wheels on the robot have turned to get displacement, and then you're going to use a gyroscope to figure out its angle. This is really consistent. However, all of the sensors drift over time, and it can't account for changes in elevation, so you're going to get inaccurate results. The second solution was to use an accelerometer, and essentially, this is what a phone or a controller might use to determine position over a small amount of time. However, small inaccuracies like balloon out into infinity because you have to integrate acceleration twice to get your displacement. And the last was vision targeting, where essentially you're going to use a camera and the known location of vision targets to figure out where the robot is relative to an arbitrary point. This is very accurate when done right and has no drift. It can't drift. However, it's very noisy, and sometimes ambiguous scenes can make rotation estimates off by a large margin. So in total, we have three bad ways to tell where a robot is. But they're all bad in different ways, so we can use them all to complement each other to get a better, more accurate estimate. This technique is called a Kalman filter. Essentially, you use odometry to measure changes in displacement and record when those took place. And then to stop it from drifting, you're going to occasionally insert a vision measurement to correct it. This is what I did to solve the original problem of shooting a basketball. And I ended up using a Kalman filter and comparing that to the known position of a goal to determine how the robot needed to turn to face it and what angle and speed the ball needed to be launched at. Plans to demonstrate the solution fell through, sadly, but the solution was robust, and I plan on using a similar positioning system in the coming season of my school's first robotics competition.